Hello, welcome to Apex Math. Today's lesson we are going to be working with inverse functions, how to calculate an inverse function and how to recognize if two functions are inverses. This would normally be done in an Algebra 2 or Common Core 2 math class. So let's start off with the function y equals 2x plus 3. If we are trying to find the inverse, what we need to do is we need to exchange the x and y values and solve for the new y. So what I mean by exchange is just switch them. So where there is an x, we're going to put a y, and where there's a y, we're going to put an x. So my new equation would be x equals 2y plus 3. And now I need to solve for the new y. So I'm going to solve for this value right here. When solving an equation that has more than one variable, I'm still going to solve it the way I would normally solve any equation, and that's the thing. Anything that's attached to my variable that I'm solving for, I deal with last. So the first thing I need to do is get rid of this 3. So I'm going to subtract 3 from both sides. That gets rid of it on this side, and on this side I have x minus 3 is now equal to 2y. Now I need to make that 2 go away because I am still trying to find and isolate the y. So since the 2 is multiplied times the y, to make it go away I divide by 2. So I divide both sides by 2. This gives me the equation y equals x minus 3 over 2. And that is one way we could possibly leave the answer. However, that makes it more difficult to graph because it's not set up in slope-intercept form. So we can rewrite this. If we remember that the coefficient in front of the x is a 1, we can say that this 2 can get distributed among both of the pieces in the numerator. So I can have y equals the 1. I'm just going to put the two numbers together and let the x sit on the side. So 1 over 2x minus 3 over 2. So I simply let that 2 go underneath the 1 here and then underneath the 3 there. And that will now allow me to have this in slope-intercept form. So this is my y-intercept, b, and this is my slope, m. So if I'm now going to graph that equation, I can more easily be able to graph the y-intercept and then follow my slope directions from there. All right, let's look at how we could do this with a calculator. So let's take that same equation, y equals 2x plus 3. And if we take that, and we have a TI graphing calculator, and we put that into y1, under the y equals button, put that in y1 equals 2x plus 3. Then we go and we use the table function. I believe it's you have to get there by pressing second table. And under there you can get a table, and the table will give you a list of all the x, y coordinates for this particular function. 0, 0, 1. If I plug in 1 here, I have 2 times 1 is 2, plus 3 is 5. If I plug in 2, I have 2 times 2 is 4, plus 3 is 7. So I can get back a table of values from typing this into my calculator under y equals. So now if I want to find the inverse, then all I have to do is again switch those x's and y's and use that switched information to graph it. So I switch this, and now switching each of these values. The 0, 0 obviously doesn't matter, but now I'm going to take and switch the 1 and the 5 and make it 5, 1, and the 7 and the 2 from the 2 and the 7. And then I can graph these values on my line, and I will have the inverse function graphed from the original function. Now, lastly, let's take a look at how do we decide if two functions are inverses of each other. Well, the easiest way to do that is to use a graphic calculator. So let's say we have the function y equals 2x plus 3, and then we're asked, is the inverse of that function y equals 1/2 x minus 3/2? Now we know it is because we just calculated a few minutes ago, but let's pretend we don't know. So if we take and we put this function into y1 and this function into y2, and we graph them on our calculator. In y3, you're going to graph the line y equals x. And the graph of the line y equals x is the diagonal line at 45 degrees that looks like this. Now, whatever picture you have on this side of the graph should be a reflection over the line of y equals x. So any graph that you have should reflect if they are, in fact, inverse functions. So if we take, let's do this one here, let's graph 3. 1, 2, 3, that's our y-intercept. Then we go up 2 over 1. So this is our line here. Probably didn't pick the best example, and I don't have a graphic calculator. But the reflection of that, which means, and a reflection is where you come down at a right angle to your reflection line, that same distance. So I should see that same line down here this should be y equals 1/2 x minus 3/2. And again, I apologize that we are not using a real calculator here, but just want you to understand the concept that the first graph should be a reflection over the line y equals x to the second graph if the two functions are inverses of each other. Basically, if you fold your graph, if you fold along that diagonal, then this should line up perfectly on that graph. And then you know the two functions are, in fact, inverses of each other. All right, that concludes our lesson on inverse functions at Apex Math. If you liked our video, please click the like button and give us some comments to let us know what future videos that you would like to see. Have a good day.